In this chapter, we will look at dynamic array formulas and functions in Excel. Dynamic array formulas allow us to reference multiple values of data at once. This is a powerful capability, as we can summarize and analyze our data more quickly than traditional Excel functions. We will go through a few different examples to see how we can use dynamic array formulas to perform calculations on multiple values of data. We'll see how we can quickly create data in rows and columns that can serve as input to other formulas. And we'll also look at the modern way to look up data, the XLOOKUP function. And finally, we'll also review the best practices to keep in mind as we use dynamic array formulas. By the end of this chapter, we will be aware of the most popular dynamic array functions, how we can write dynamic array formulas to perform a flexible, quick, and robust analysis, and how we can pair dynamic array functions with traditional Excel functions to supercharge our analysis. Let's get started. Let's start to look at how we can use dynamic array formulas. Usually we can rely on Power Query to automate data transformation and reshaping. But let's see how we can use dynamic array formulas to replicate this functionality of Power Query with some basic examples. We'll use this small data table to be our source data today, and this could potentially be a much larger data set with more rows and more columns. But this data set has 3 columns, a GL account number, a date, and GL amount. Let's start by filling in some data under the tax header to the right of this table. And what we want to do is we want to multiply each value in the GL amount column by our tax rate of 5%. And we want to take this result to populate the amount of tax due on each of our line items. To accomplish this, we could reference a specific cell, like cell C3, and multiply it by 0.5, or 5%. And then we could drag or fill the results of this formula down. But we can also accomplish this by using a dynamic array formula. So if we reference cell C3, which is the first row in our data table, and then type in colon C12 to highlight this entire column, we can then multiply that by 0.05. And with this formula, we have calculated the tax for each row in our table without needing to copy down any formula. Within the source cell, where we entered the formula, we defined the array that we wanted to do our calculation on, and the results spilled down underneath. We can also reference multiple arrays within our formulas. If we wanted to subtract the tax from the GL amount column to return the net amount, we could use C3 to C12 minus E3 to E12. And if we press enter, we get the results. So an advantage of using dynamic array formulas is their flexibility. And we can not only create new arrays from columns and vertical arrays, but also horizontal arrays as well. Let's fill in this matrix to the right. If we wanted to multiply each of the amounts in the column with each of the tax rates, we can achieve this with just one formula. If we say equals H14 to H8, and we want to multiply this by I3 to K3. Once I hit enter, all the results are populated. And in fact, we could recreate this entire matrix and make it fully dynamic by using a dynamic array function called sequence. And the sequence function creates an array based on the parameters of the function that we can specify. So let's start by recreating this amount here. So we can use the sequence function. And the first parameter is the number of rows that we want. So we want 5 rows. Then the second parameter is how many columns. We just want 1 column. And then we have the number that we want to start the array with. That's 5,000. And then the amount of the step, or how much we want to increase from this starting number in each row. And I'm going to put 1,000. And now we have these same numbers that appear above here. Now let's do the same thing with the tax rate. We can use the sequence function again. This time we want just one row, 3 columns. We're going to start at 0.05 and increase by 0.05. And then once again, we can populate the matrix inside. We want to multiply our amount by the tax rate. And you see, once we select the dynamic arrays that we've created, we get this hash syntax. We see the source cell for the amount that's H14, and then the hash symbol after it. And the same thing for our tax rate. This allows us to reference a dynamic array in its entirety, and means that our results will update as our source arrays update too. So let's update the formula for our amount array. I'll click in the source cell, and instead of 5 rows, let's change this to 10. And right away, everything expands. We can update the tax array as well. Instead of 3 columns, let's change that to 5. And our analysis automatically updates. Now that we've taken a look at dynamic array formulas, and at our first dynamic array function, let's explore a few other functions that we can use as well. Let's take a look at a few more dynamic array functions. For the first example, our goal is to return a new table of data here that filters our source table to return all of the rows where the GL amount is greater than 3,000. And since we're filtering data, we can use the filter function. The first argument is the array that we want to filter, and in this case we can select the entire source table. The second argument is how we want to filter the table, which is where the GL amount column is greater than 3,000. And we get our results just that quickly. Now, one thing that we might notice is if we click anywhere in the array outside of the source cell, I can try and delete it, but nothing happens. We can only delete this dynamic array from the source cell, like this. And this is because all of the results of the dynamic array spills from this source cell. If I enter some data in any of the cells within the dynamic array, like here, if I were to type in new data, we now get an error message in our source cell, spill, and we see a preview of where we want the data to populate, but we see that the data that we entered is blocking the spill from happening. So let's press delete, and the data appears again. A great feature of dynamic arrays is how it responds to update in the source data. We saw this previously when we updated some of our source arrays, but it also works for Excel tables as well. Let's add a new row to our source data here. We'll add GL 5000, and we'll say that it has an amount of 4,235. And as we update this source table, we see that our dynamic array updated immediately. So dynamic array formulas work just like other Excel formulas do. They will update immediately. In our next example, we want to return the average GL amount for each of our GL accounts. Our first step is to return a list of all the distinct GL account numbers from our source table. Therefore, we will use the unique function. Let's put this under our GL account header over here. I'll use the unique function. And the first argument, we need to define the array. And in this case, it's not our entire table, but just the single column from our source table, the GL account column. Let's press enter. Now, when we look at the result, we are returning a list of the unique GLs from the table, but they're not in the correct order. They're in the order that they appear in our source table. And what I want really is for them to appear from smallest to largest. So what we can do is we can use the sort function to achieve this. Let's go back to our source cell, and we can wrap the unique function with the sort function. And by default, this sorts the input, which is our list of unique account numbers, from smallest to largest. And when we do that, our output now appears in the correct order. Now we need to add the averages. And we can do this using a different Excel function, average ifs. This is a great feature of using dynamic array formulas, is that we can pair them with other functions in Excel as well. So let's use average ifs. And the first parameter is the average range. So let's pull in the column from our source table. And then the second argument is our criteria range, which will be the GL account column from our source table. Finally, we have our criteria, and we will use our unique list that we just created from I3 to I11. And once I hit enter, now we have the averages for each of our unique GL account numbers from our source table. So now let's update our source table once again. Let's add a new GL, and we can add a GL balance of 5,000. So this is interesting. Our example from the last lesson updates correctly. Our filtered table, we see GL 8,000 and a 5,000 GL amount. But in our example from this lesson, our GL account number updates, but the average doesn't. When we add an extra row, we see that it's not expanding. And that's because if we go back to the source cell for our averages, I've hard-coded the range of values here with my average ifs. What I want to do is reference the dynamic array, just like how we reference a table or a column with an Excel table. And that way, when the array gets longer or shorter, my results will still be returned as expected. So again, the syntax to do this is we're going to reference the source cell, and then we're going to use the hash symbol. And now when I do that, our averages has expanded to include this new GL. Earlier in the course, we saw how we can look up data, how we can add additional information to our data by matching data from another table. The modern way to do this is by using the Lookup function. Lookup is a flexible function, as it allows us to look up and return values from both a vertical and horizontal array, while using the same function. Let's start this example by creating a lookup table that we can then use to reference and expand our source table over here. We can create an array of unique GL accounts from our source table. So once again, we can use unique and reference the GL account column from our source table. And then what we want to do is to add just some random values to the rate column. And to do this, we can use the random array function, which works in a similar way to the sequence function that we've seen earlier. So rand array, and the first argument is the number of rows. Now rather than hard coding in the number of rows from our GL account array here, we've seen earlier that that's a bad idea to hard code something in, I need to dynamically enter how many rows appear in this array. And to do that, we can use the count function. And we can use our dynamic array as input. And all this does is count the number of rows in the array. And that way, our rate column will always be the same length as the GL account column to the left. For number of columns, we just want 1. And we can set a minimum and maximum range for these random values. So let's put 0.1 and a maximum of 0.9. And now we have our list of random numbers. Let's start with a horizontal lookup by filling in this header to the right. Let's create a horizontal array of GL account numbers using the sequence function. So I can use sequence. For the number of rows, we'll use 1. For the number of columns, we'll select 4. We'll start with the number 1000, and we'll step by 1000. So now we have 1000, 2, 3, and 4000. And now we can look up the associated rates from our lookup table here, and we can put these rates in the row underneath these headers. So let's use xlookup. And the first parameter of the function is the value that we want to look up. So this is our horizontal array here. Our second parameter is the column to search for this lookup value, which is the GL column from our lookup table. And the third parameter is the value to return as a result of the lookup, which is the rate column from our lookup table. We can see that all the parameters in the function are references to dynamic arrays. So let's close the bracket and hit enter. And just like that, we have the matching rates for these GL accounts. Let's move on to our next example, adding the rate from our lookup table into our source table with xlookup. So let's add a new column, rate. So once again, we'll use the xlookup function. So the first argument is the lookup value, which is the GL account column from our source table. And when we select it, make sure to use a structured reference to the column. So let's just add an opening bracket and ensure that we're referring to this row. The second argument is the lookup array. So this is the GL account column from our lookup table. And the third parameter is the value to return as a result from the lookup, which is the rate from our lookup table. But this doesn't work. We get a reference error in our table here. And the reason for this is if we click back into the first row where we define the formula, here we're referencing a dynamic array that starts in cell F2 and G2. But if we go down to the next row in our source table, this changes to F3 and G3. So what we need to do in this cell is make sure that we anchor our references to these dynamic arrays. And we can do this by pressing F4 to anchor these references. And now when I make that update, we get the correct lookup and the rate is added to our source table here. We can test to make sure that this works by adding a new GL account number to our source table. We can add 5,000. And once we add that GL account, we see that our GL account lookup table expands to include this new GL account. We get a random rate assigned to it using the random array function. And then this rate is added back to our table, back to our source table, because we've looked up this value. XLOOKUP and dynamic arrays are a powerful, formula-driven way to quickly build a dynamic analysis in Excel.
Next up, let's take a look at the group by function, which is available in Microsoft Excel 365 as a way to aggregate structured data. To help walk through this example, we've got a small table here of loans data, which details the type of loan product that was issued to a specific customer, when it was issued, what the credit limit is on that, and what the current balance is. So suppose we want to take a grouped total by product here. So we can use the group by function. We'll click and select the products that we have available. Then the second argument, we click the column that we want to group or aggregate. And finally, the third argument, we have to describe the type of aggregation we want to do if we come across more than one value for that field. So here we've got those 4 values, and we want to take a sum in this case of those 4. And that returns an aggregated table with a sum of each group. Now, this is a dynamic array, so it spills out from that first cell across the table, and so we have to make sure there's nothing in the way of that spilling array. Now, when we actually look at the formula here in the group by, if we expand that, we can see we're just referring to cell ranges, which aren't particularly helpful. So there's one trick we can do there is to click on the table, use our Control-T shortcut, and actually format this as a table. We can give the table a name like loans data, which then means that when we rewrite the group by formula and click on those column headers with that black arrow, we actually see more meaningful names in the formula. So we can see, okay, group by product, fine. Show me the aggregated balance, and when presented with multiple values, create that sum. So we get the same result, but we have a more auditable formula, which shows very clearly the link to the table. Now, one cool thing we can do with this formula is, instead of returning a single aggregated column as the result, we can actually combine multiple columns. So here I've taken for each row the credit limit, deducted the balance, and then got the sum of each, which effectively gives me the sum of all remaining credit limits across those products. And so there's all sorts of clever ways that you can use this function to aggregate and simplify your data without resorting to a pivot table. The neat thing about using a dynamic array formula to do this is that you don't have to rely on a pivot table or updating that table to see the new results when you add or subtract entries from your structured data table. The formulas are flexible. They allow you to build in different calculations, different subtotals, and different ways of aggregating the data. And so they represent yet another way that Microsoft is bringing these sort of productivity formulas in to help you transform your data on the fly. Microsoft Excel 365 has yet another new function called Pivot By, which we can use for data analysis to help us transform our data. Again, I'm working with the simple table of loans data. So each row represents a loan initiated on a specific date to a particular customer, and we have the customer IDs but not the names here, the product they were given, and the current balance and credit limit that they have on that product. So my data is formatted as a table, which is going to make my formulas more auditable. I'm using the Pivot By function. So first I need to define what fields I want to show in my rows of my pivot table. And so for that, I'm going to click on the column header for product in this case, which I want to see in my rows. So I look for that black arrow, click on the column header. And then for my second argument, I want to show a list of dates across the top of my table. So let's again look for that black arrow on the initiated column. My third field is going to be the balance column. That's the one I want to aggregate across those cells in my pivot table. And fourth, I have to define how I want that aggregation to happen, and so I want to take a sum. Now currently I'm seeing an individual date across the top of my pivot table. Now I don't want to see that much detail. Maybe I want to manipulate that to just show particular months. And so the neat thing is that I can do this within my Pivot By formula. I can manipulate my row and column headers. So in this case, I'm going to use the text function on that initiated date column, and I'm going to present it as year and month. So once that change has been made, my data is presented and aggregated according to those transformed values. Now I get one value per month per product. And again, just like the group by formula, because this is a dynamic array, it responds dynamically to me removing or adding rows from the source data table. So another great example from Microsoft there of bringing data analysis techniques right into Excel that avoids us having to create a pivot table every time, and we can do this kind of analysis on the fly and keep it updated to our source data.
In this chapter, we examine dynamic array formulas in Excel. Working through a few examples, we saw some of the important aspects of these formulas. We saw how we can refer to multiple values of data in one formula, some popular dynamic array functions available for us to use for our analysis, the spill behavior of dynamic array formulas, and how we can future-proof our solution, being aware of how to properly refer to the input and create flexible output for our dynamic array formulas. We are now ready to move on to the next chapter in the course, using pivot tables to analyze our data in Excel.